Hello guys, this is Sharanya. Today I am going to explain NET June 2018 booklet C question number 41. The resolvent kernel for integral equation. This is our integral equation and we need to find the resolvent kernel for integral equation. 4 options are given. So first we should know the formula for resolvent kernel. So resolvent kernel formula is, you should know the formula. See, lambda to the power m minus 1 km of x comma t. Okay, this is km of x comma t is iterated kernel and this lambda is our eigenvalue. Okay, so now see, we got the formula for a resolvent kernel and see this equation. This is a Volterra equation. See the limit 0 to x, so it is a Volterra non-homogeneous equation. If you compare this to the general equation of Volterra, phi of x is equal to f of x plus 0 to x lambda k of x comma t phi t dt. Okay, if you compare this equation and this given equation, then see, this f of x is equal to x square, this k of x comma t is e to the power t minus x, correct? So first we need to find the km of x comma t, which is iterated kernel. So the formula for iterated kernel is k1 of x comma t is equal to k of x comma t, which is given as e to the power t minus x, correct? Just compare this and this. So e to the power t minus x, correct? And k m of x comma t is equal to this integral t to x and k of x comma s and k m minus 1 of s comma t ds. Okay, so this is the formula for iterated kernel. Okay, so this k m minus 1, this we can find from here. See, first k1 of x comma t we already have e to the power t minus x. We need to find k2 of x comma t, right? So k2 of x comma t, just put in the place of m we will put 2. Okay, so we will get t to x, k of x comma s will be e to the power s minus x, correct, into k m minus 1 means k1 of s comma t. So k1 of s comma t will be e to the power t minus s, correct? See from here, this is ds. So just this is e to the power s minus x and t minus s, just add the power, you will get t to x integral e to the power, this s and s will get cancelled, so you will get t minus x ds. When you will solve this, you will get e to the power t minus x into x minus t, correct? So you got k2 of x comma t, right? So after getting k2 of x comma t, now I am going to find k3 of x comma t. See, after finding k2, k3 or k4, we can generalize the km of x comma t, right? So I am going to find k3 of x comma t now. k3 of x comma t will be equal to integral t to x. See the formula, t to x, k of x comma s, k m minus 1 s comma t. So k3 of x comma t will be k of x comma s, k2 of s comma t. Okay, so this will be equal to k of x comma s, k2 of s comma t. Okay, so this will be integral t to x, k of x comma s will be e to the power s minus x into k2 of s comma t. So in the place of x, here you put s. Okay, so you will get s minus t e to the power t minus s ds. Okay, here also ds. So solve this. This is e to the power, two terms are there, so just add the parts. You will get e to the power s minus x plus t minus s. So s and s will get cancelled. You will get t to x s minus t ds. Okay, so now you will get e to the power t minus x into s minus t ka square by 2, right? So the limits are t and x. So apply the upper limit and lower limit. You will get e to the power t minus x into x minus t square by 2. Okay, when you will put t here, so you will get 0. So you got k3. Okay, Now find k4. See why I am going to find k4. See, this is k3, this is by 2. So maybe in next term I'll get 2 square, or maybe factorial 2, this is, so factorial 3 maybe I'll get. So that's why I'm going to find k4. Then I can generalize the next term. t2x k of x comma s, this will be k3 of s comma t ds. Okay, so just put the values. t2x, this k of x comma s will be e to the power s minus x. k3 of s comma t will be s minus t square by 2 e to the power t minus s ds. So just add these powers of these two terms. You will get e to the power t minus x into, see, s minus t square. This will become, after integration, s minus t cube by 3. So this will be, 2 is already there. So 2 into 3 will be 6, or you can write it as factorial 3, right? So you got k4 is equal to this value. So now you can generalize the next term, right? You have k3 like this, x minus t square by 2. See, okay, I need to put here upper limit or lower limit also, t2x. So just applied the upper limit and lower limit, you will get k4 is equal to e to the power t minus x into x minus t cube by factorial 3, right? So can you generalize this? Km of x comma t will be e to the power t minus x into x minus t to the power m minus 1 upon m minus 1 factorial, correct? So you got km of x comma t, right? Now what I gave the formula for resolvent kernel? Resolvent kernel R is equal to summation of lambda to the power m minus 1 into km of x comma t, right? What is lambda here? Lambda is the eigenvalue. So you can see the question. In the question, lambda value is 1, right? So see here, lambda will be 1. So this will be m is equal to 1 to infinity km of x comma t, right? Because lambda is 1. So just open this. This will be m is equal to 1 to infinity km of x comma t value is e to the power t minus x minus t to the power m minus 1 upon m minus 1 factorial, correct? So e to the power t minus x term we can take outside the summation, right? Because here no m is not here in this term. So e to the power t minus x I take outside. This will be m is equal to 1 to infinity x minus t to the power m minus 1 upon m minus 1 factorial. See, this is the formula for e to the power x, right? Okay, I'll expand this and show this is e to the power t minus x. After expanding this, we will get, first put m is equal to 1. So 1 minus 1 power will be 0, and 1 minus 1 0 factorial is 1. So first term you will get 1 plus second term m is equal to 2, you will get x minus t, plus third term x minus t square by factorial 2, right? Like this you will expand and see, this is the formula for e to the power x minus t. That is e to the power t minus x into e to the power x minus t, right? So just add the powers, you will get e to the power t minus x plus x minus t. So x and x get cancelled, t and t get cancelled. So you got r is equal to e to the power 0 is equal to 1. So we got resolvent kernel value is 1. See the resolvent kernel here, options. See, second option is 1. So in this question second option is correct. If you like this video, please subscribe my channel. Thank you.